Please welcome the Dean of the School of Medicine, Vikas Sukhatme.
The year is 2036, and we're sitting around, and who's the we? It's all of us, supporters of the school, supporters of Emory School of Medicine, alumni, students, faculty, and we get together periodically. We keep an eye, especially on medical developments that are coming out of Emory. And as we get together for the first time in a few years, there's something rather interesting that we notice. We don't seem to have aged. We look the same as if we looked the way we looked 5 years ago. Hang in there, I'll tell you why in just a second. We've been reading the news about an influenza vaccine that's universal, that we won't have to take every year. We're reading the news about how Alzheimer's disease is actually an infection. I'm making some of this up. We'll read the news that a combination of drugs that already exist that cost pennies can be combined together, non-cancer drugs that can be put together in cocktails that hold cancer at bay for years. And we have read about a pill, a poly pill that contains several different ingredients that stops aging. A pill that was discovered at Emory, that was trialed and approved by the FDA 5 years earlier. And guess what? We're all taking that pill. Now, is this fact? Is it fancy? I can't tell you for sure. But I will tell you that there is a good likelihood that some or more of these events will take place. Why do I say that? Why do I say that with some conviction? It's because this is a unique time in the history of medicine. And I wouldn't have been able to say that in all honesty just a few years ago. I'll tell you why it's unique in just a minute. But what that means is that for the first time in the history of medicine, we have a chance to take on some of the toughest problems and have a good chance that we will succeed in conquering them. Now, why is this a special time? It's special because a number of forces are coming into play, and they're converging, and there's a synergism in these forces. You've all heard about the omics revolution, genomics revolution. We're talking about DNA. But there's RNA that now you've heard about. There are proteins. That's proteomics, transcriptomics, metabolomics. In other words, for the first time ever, we know the parts list of what makes us up. It's as if all the parts of a Boeing 787 were sitting on the runway, and we'd never seen the beautiful aircraft. The challenge now is what? How do you make an airplane out of all these parts? The second major revolution is the IT revolution, IT/artificial intelligence revolution. The ability to gather, to transmit, to visualize, to mine large data sets of all kinds, but especially patient-related data, and to use that data in a meaningful way to individualize, in other words, personalized therapy that is directed to a given patient based on their data and patterns one can discern thereof, so that they get the right drug at the right time, in the right schedule. That's personalized or precision medicine, and it is coming for sure. It will even help us predict who's going to get into trouble, who is going to develop cognitive decline a few years from now, and therefore, what can we do about it, especially in that group of people. The third revolution is that a number of technologies have happened. They need not have happened at this time. In some ways, it's a bit of a fluke. CRISPR, you've heard about, the ability to edit genes, take genes in and out from mice, and then see what happens. That's how we'll figure out how each part plays a role. But in addition, we can take cells from the human body, from patients, modify them using CRISPR, and reinsert them back so that they have new and exciting properties, for example, to attack cancer. So it's a new kind of drug. It's not a small molecule, it's not an antibody, it is a cell. In some cases, those cells will be derived from patients themselves. In some cases, they will be more universally applicable to many patients. So that's why I'm reasonably confident that there will be some very significant advances in the next few years. To take advantage of that, we have put together, we meaning 200 faculty or so, a research strategic plan and an education strategic plan. And let me just spend a couple of minutes on the research strategic plan first. There are 5 pillars to this plan. The first is we need to recruit about 150 new faculty to the Emory School of Medicine, some perhaps jointly with other departments, that crisscross many different areas, folks who have interdisciplinary ideas, because most of these problems require an interdisciplinary approach. People who work with data, people who work in the laboratory, and people especially who can go back and forth between these two kinds of work. We're recruiting in that 150, in addition to the 150, so-called 4 to 6 game changers, folks who might be late associate professor, early full professor level, who are paradigm shifting in certain ways. Now, we don't want to ignore those who are here, and there are plenty of good people here already. And so there is organic growth that we want to have. How do you encourage interdisciplinary sorts of work? How do you encourage people to commercialize technology? So we've called these the I3 or I-cubed awards, which stands for Impact, Innovation, and Imagine Impact and Innovation Awards. And they come in different flavors, each one rewarding a specific kind of enterprise that we want to foster. We'd like to double or triple those awards. Right now, we give out about $1.5 million a year. The return on investment just in 3 years has been 5 to 1 already. We'd like to double or triple that number. A third major pillar of the research strategic plan is around partnerships. There are some incredible institutions around here. Children's and Emory have struck a very interesting partnership just in the last 2 years. The first time they fundraised together, we got $100 million. And I can assure you there is more money coming if we can work together across different institutions. Georgia Tech is one such institution that we need to work closely together for a whole number of reasons. We have one joint department in biomedical engineering, ranked second now in the United States. We can do equally well in many other departments, not necessarily having to join them, but just making sure that the engineers, so to speak, understand our problems, our clinical problems, and we understand the capabilities that science and engineering has to bring to the table. Grady is another institution where we already, 80% of the faculty come from Emory School of Medicine. We can do a lot more with. And so we are making plans for putting all of this into motion. Some of that requires money, of course. A lot of it requires money. But I have high hopes that it will lead to a great deal of success. A fourth piece of the plan is infrastructure. Biology is no more sitting around one person in the lab doing their thing and great things coming out. It's just not. It's team science. It's instrumentation that is fairly sophisticated. It is coming out the way physics was just 50 years ago. Big machines, maybe not quite costing $100 million like accelerators do in physics, or even $1 billion, but in the tens of millions. That infrastructure is critical to recruit top faculty and to retain them. We call these core facilities. Other parts of the infrastructure, buildings, shining new buildings. And the Health Sciences Research Building 2, as you may know, that's coming up right around the corner here, is one such example. It'll be iconic. One of the most pleasurable parts of my job in the last few years is becoming a pseudo-architect and designing this building. It will look very nice, I assure you of that. So please come and take a look. And finally, a culture of innovation and entrepreneurship. I've just singled that out. We're not just talking about certain centers devoted to that, and there are several I can talk to you about, but to put in every aspect of our mission, not just in research, in education, in clinical care, how can we be more innovative? What are the processes that need to be in place to make this happen? Can we teach innovation and creativity? And can we study it? And that's something that we are putting into motion. Now, on the education side, there's an equal number of things going on. In the interest of time, I will curtail that a little bit, but we want to be equally innovative. We want to educate folks, whether they go into becoming teachers themselves, or to practice medicine, or to do research, or to be entrepreneurs, or to change policy in the United States and abroad. We want to train leaders, which means their education has to be broad. They have to be folks who are excited about lifelong learning, who understand what they can do for the community, who understand data, science, and are literate in that in a variety of ways, who understand that medical knowledge is moving at an incredible pace. As you know, the standard joke, we teach you a lot here in the 4 years in medicine, half of which will disappear. We don't know which half that is. More than half is going to disappear as we go ahead. So there's a lot we're going to incorporate: leadership, design thinking, ideas of this type, preventative medicine, and not just preventing disease, but how do we perform at our peaks, which is very different from the avoidance of disease, and of course very different from the treatment of disease, which is where most of the focus in medicine is today. All right. So I've told you a lot. I hope you will join me in this adventure. I assure you it will be ups and downs, unpredictable. But one thing I can assure you, if you do join in, just by virtue of your joining in, you will stay young. Thank you.